An equation is balanced when the different atoms of the elements of the reactant or the elements on the left hand side is equal to the product, or is equal to the right hand side. That is to say, for our example here, we want that the number of hydrogens on the left hand side of this equation is equal to the same number of hydrogen on the right hand side, and the number of oxygen on the left hand side is equal to the number of oxygen on the right hand side. Now one thing you can do is that you look at the hydrogen and you write it for you to see it clear. We have hydrogen to be 2 here, we have oxygen to be 2 here. We draw a line here. Here we have hydrogen to be 2, which is good because then they are balanced. But oxygen, you see, oxygen we have 1, so there is something we have to do to make the oxygen also balanced. The thing is, if for example I put 2 here, I get the oxygen to be 2 now. So now the oxygen will be 2, but you see my hydrogen now becomes 4 because I have 2 times 2, which becomes 4. Now for us to get the hydrogen as well to be 4, if we put 2 here, we get the hydrogen to be 4. And then now we have hydrogen 4, oxygen 2, oxygen 2. So this equation is balanced. One student will say, oh, but why did you bother yourself to put the 2 here? You could have just put the 2 as a subscript. Unfortunately, you cannot do that, because if you do that, then you change the total, you change the compound that we have here totally. Here we have water. If we were to put 2 here, it's not water anymore, it's another element, it's another compound altogether. So you should never put, when you're balancing an equation, only put in front here, that's put coefficients, that's all. Now let's look at another example. Another example, we have this equation here. I cleaned this a bit. We want to look at this equation here. When we look at this equation, we can see that we have on the left hand side, or the reactant side, we have zinc to be 1, we have hydrogen to be 1, we have chlorine or chloride to be 1, we have Zn to be 1, we have zinc 1 here, we have the chlorine or the chloride to be 2, and then we have hydrogen to be 2. So the zincs are okay, we don't need to do anything, so we leave it for the time being. Now let's look at the hydrogen. We have 1 here, we have 2 here, so maybe it's good for us to let's put 2 here and see what will happen. So when we put 2 there, we see that we have 2. The hydrogen will change to 2, and the chlorine or chloride will change to 2. Oh, it's already balanced. We have 1 1 1 1 2 2 2 2. So we've balanced the equation now. Now let's look at another example. Now we are given this to balance. So we start as usual. We write our potassium. Potassium is 1 here. Potassium is 2 on the right hand side. We see oxygen. Oxygen is, let's see, 1, and then we have 2 here, so the oxygen is 3. On this side, we have on the right hand side, we have oxygen to be, this is 3 plus 1 is 4. Now let's look at our hydrogen. We have hydrogen to be 1 on the left hand side, and then we have hydrogen to be 2 on the right hand side. Now the last element we have to write is the carbon. We have carbon to be 1, and then we have our carbon here on the right to be 1 as well. So we see we need to do something to the potassium area to get it to 2. So let's put 2 here first and see what will happen. We put 2 here and this becomes 2. And since this 2 affects this, we have 2 plus 2. Now the oxygen is 4. Because we have 2 oxygen plus 2 oxygen gives us 4. Now the hydrogen, we have 2 hydrogen. So the hydrogen is 2. Oh, you see it's already balanced. We have 2, 4, 4, 4. We have 2, 2 here, 4, 4 here, 2, 2, and 1, 1. So the equation is now balanced. This is how to balance a chemical equation. It's just doing mass, checking each element and trying to see that each element on the left hand side are the same number of atoms as the elements on the right hand side. Thanks for watching. Please help me by subscribing to my channel. Bye.